when a user sits by his computer and launches the web browser, it means that a command has been issued to fetch or to get the home page, and the home page now is returned to the user's web browser by the protocol, which is the HTTP, that is Hypertext Transfer Protocol. So the Hypertext Transfer Protocol is responsible for the transmission of files from your web server to the web browser of the user. So when a user issues a get command from the web browser, which is configured by default on the web browser, so when a user launches a web browser, of course the home page, most of the times the home page is what the command is given. So it launches the home page that has been set either by default or customized by the user. So the HTTP protocol fetches the information as stated in that get command. So now the transport layer defines how this information is conveyed to the user. A passenger can decide, I want to move from Ojota to Oshodi. So if the passenger can decide, okay, how am I going to move from Ojota to Oshodi? I can decide to move from Ojota to Oshodi by either taking a cab or by taking a bus or by taking a taxi, as the case may be. So if I decide to take a bus, there might be some form of delay, there might be some form of lag and in time for which I'll get to my destination, or I've shielded myself of the risk of breaking my leg as against taking a bike. So that is what a transport layer defines. It defines how the data defines data delivery. So the transport layer is responsible for the delivery of data from one computer to another computer. So transport layer protocol, there are also other protocols in the transport layer that are referred to as the um, transport layer protocol as TCP or UDP. So transmission control protocol or user data gram protocol. So transport layer provides what we another function like error recovery. So the transport layer is known to provide services for transference of data from source to destination. So now that will lead us to the network layer. So the network layer for the TCP IP model, the original TCP IP model, the network layer is actually not referred to as a network here, but it's referred to as internet layer. So the internet layer. So the internet layer basically defines logical addressing and routing, and the protocol here is the internet protocol. So logical addressing and routing. So addressing, the analogy here, just like in the case of transport layer where we define that, so we say transport layer guarantees data delivery, and the analogy has to do with a passenger moving from a place to place, considering what option to transport by, to commute by, perhaps use a bus or a cab or a bike as the case. So if a passenger decides to make use of a car, there is guarantee that the passenger is not going to be beaten by the rain, nor is it going to have, nor the probability of sustaining a leg injury to collision, a minor collision, is avoided, because that is what is obtainable when you decide to travel by a bike, because even a minor collision can lead to leg injury. So data delivery is guaranteed, or data services is provided by the transport layer, and different means of transmitting data will be what would guarantee the delivery of the data. But in the internet layer, which is in the network layer, in the new TCP/IP model, defines internet protocol. So the internet layer defines logical addressing and routing. Here, let me use an analogy of a post office. So an address is given to a letter, so for it to be delivered, so definitely for a letter to be delivered to a particular location, there must be an address. You must have a unique address for the location. You must have your own unique address, and the location for which the letter is to be delivered will also have its own unique address. So what IP, which is the internet protocol, defines two kind of addresses for the internet layer. So we have the IP version 4 and IP version 6. So these are the two kinds of addresses we can have in the internet layer. The analogy here for routing, it involves the destination. Knowing the destination, okay, there are some letters that will be going from one state to another state, and some are going from one continent to another continent or country to country. So the way a letter going to a nearby house in the neighborhood will be handled is different from the way a letter going to another country will be handled, or going to another continent will be handled in that case. So logical addressing defines the IP address, unique addresses, so that each host will have. So every host on a network will have a unique IP address, and routing will determine of what group of addresses receives what kind of information. So routing will define the location in which a group of packets, which is the data representation for information on the internet layer, is addressed. Okay, the packet is going to be delivered to a group of user, so at a particular location. So it is the internet layer that defines how these packets are to be delivered. So now the IP version 4 is the older form of addressing, while the IP version 6 is the newer one, and obviously the IP version 4 is no longer in vogue or used in some organizations that don't necessarily need to connect to the internet. But IP version 6 is what it's rampant, and it's available and has been made available to solve some problems that are related to the use of IP version 4, which we'll be expanding on in our subsequent videos. So now, before I go to the link layer, I want to establish what we refer to as same layer interaction and adjacent layer interaction. It has been established that different layers, the lower layers, offer services to the upper layers. For instance, the transport layer offers service to the application layer, the network layer offers services to the transport layer, and so on. So adjacent layer interaction refers to a kind of communication that holds on the same computer. Here the lower layer offers services to the upper layer, so the internet layer is offering service to the transport layer. However, a same layer interaction involves two distinct computers, in which the transport layer is sending information which will be received by the same transport layer on a different computer. So now a transport the transport layer on the first computer, the information header is added. So let's say for the transport layer we have our information. We refer this as the header. So this is the header, this is HTTP, and we have our data. So the header is included here on the first PC1, and on PC2 we have the same header and data received by the same layer, the same transport layer. However, for adjacent layer interaction, the data sent by the transport layer is received in the internet layer by what? Encapsulation. Okay, so now the internet layer receives the data in the transport layer. So we have transport layer data, which is what? HTTP. This is the header in the transport layer, and this is the data. So when it gets to the internet layer, an additional header is included in the network layer, which is what? The IP, which is the IP address. So in this case, we have our header, which is what? IP, which could be IP version 4 or 6 as the case may be. So now we have the header and we have the data. So adding header to different data as it moves down from one layer to the other, or as it transfers from upper layers to the lower layer, is what we call encapsulation.